Students will continue the session with peptide bond and its properties. So peptide bonds are a covalent bond. These bonds will be formed in a stronger state. So you will get the bond formation and the bonds will be very stronger when compared to non-covalent bond. So your peptide bond is one of the covalent bond and it is also called as amide bond. A peptide bond is also called as amide bond. It is formed between alpha nitrogen atom of one amino acid and the carbonyl carbon of the next amino acid. So if we see the first amino acid COOH group will be involved and the next amino acid, the second or subsequent amino acids NH2 group will be involved. So your COOH group and NH2 group will combine and water molecule will be released. So H2O will be released. So now you can see two molecule of H and O if it is released. The peptide bond will have a structure C double bond O. In the opposite direction, NH will be there. So you call this as a dipeptide because two amino acids are there and it has peptide bond in between that. So C double bond O, NH will contribute for the peptide bond structure. So isopeptide bonds refer to amide bonds between side chain amines or carbonyl carbons on the side chain rather than alpha amine or alpha carbonyl. So we have amino acids COOH group and the second or subsequent amino acids NH2 group followed by this water molecule will be removed and you have a dipeptide. C double bond O NH. So the peptide bond structure will be C double bond O NH will be the peptide bond structure. So this will be the peptide bond structure. Now we will see the properties of peptide bond. So peptide bond, they are not broken by warming or salt concentration. That is why whenever we use salt, little bit of salt, or when you heat it up, nothing will happen to your peptide. So when you heat it or when you boil it, the peptide bond will not break. And when you add more salt to it also, it will not break. They can be broken only by representing them to the corrosives, some corrosive material or some alkaline material with high temperature. So when you increase the temperature and add it to corrosive or a base or alkali substance, only then the peptide bond will be broken. And the peptide bonds are inflexible and planar bonds. So it will be planar in structure. So as we saw here, it will be planar. It will not be projected above or below. So C double bond O NH will be planar in structure and it is inflexible. So you cannot flexibly move the peptide. So along these lines, balance out the protein structure with partial double bond in nature. So this only will balance the peptide bond, the entire protein, with little bit a partial double bond, but without breaking of your peptide bond. And most of the times, the configuration of the peptide bond will be trans configuration. When you take in case of isomer, trans conformation will be seen in case of the peptides or peptide. The peptide bond also contains incomplete positive charge, which means a partial positive charge gathering, especially in the polar hydrogen molecules of amino acids, and fractional negative charge gatherings, polar oxygen particles of carbonyl gathering. So wherever you have your electronegative atom, the negative charge will be accumulated. Wherever you have electropositive atom, positive charge will be generated. So this is not completely because of ionization, it is completely because of partial positive and partial negative charge is because of electronegativity and electropositivity of the atom. So you have to remember it is not broken. It can be broken only with corrosives and base and it will be inflexible, planar in bond and the conformation is trans conformation. It also has incomplete positive charge and fractional negative charge with respect to the electronegative and electropositive atom. So this is the property of peptide. This will come to the end of this session. We'll see the other topics in the next class. Thank you, students.